Okay, so this is V1 video for my ME 435 project. My name is William Bigstein. First, a quick introduction to this project. For this project, we were told to go and take a LiDAR sensor and make a point cloud of an object on campus. In fact, over this entire semester, we've been working to create LiDAR, working with LiDAR sensing. I decided, oh, wait. I decided that the thing on campus that I wanted to measure was the Idea Factory balcony. I have very fond memories of going to the Idea Cafe pretty much every day for lunch. And it's one of the few things at UMB that I'm truly going to miss, because I think personally that those $7 mac and cheese and chicken nuggets absolutely steal. In particular, mapping this entire thing would be difficult and unfeasible for this project. So I decided that I'm going to try and map only the center gardens and the surrounding bench. So, sensor design. The theory of LiDAR is that you have a camera and you have a laser. And the laser shoots an object and reflects to the camera. And based off of how far away the laser is from the center of the picture, the center of the lens of the camera is how far away that object is. So you can use photos to tell distances. This is my sensor. Ooh, ah, there are others like it. This one is mine. A couple things I want to note. Up here is the camera. The camera, it takes photos. It's a camera. It is connected to a Raspberry Pi. The way I controlled this sensor was the Raspberry Pi was connected to a VCN, which was and my computer was on the other side of the VCN server. Therefore, I could control this sensor from my computer. Next, down here is the laser. The laser, when the sensor was on, was just always on. It wasn't blinking, anything like that. There was an Arduino. The Arduino was one providing power to the laser, and it was telling it to turn on. Not shown here because I took it off, but the Arduino was powered by a 5-volt battery, which simply plugged in. Over here, you'll notice that this entire sensor apparatus is on top of a tripod. And one of the things is right where the tripod meets the apparatus is a flat area. So in order to tell what angle my camera was taking pictures at, I would pull up the Measure app on my iPhone, and I would set it to level, put it on this flat area, so that as I went and turned the sensor up and down, I would be able to tell the IMU angle relative to the ground. Meanwhile, you have the tripod itself. With the tripod itself, you can control the height of the sensor. You can also rotate the sensor, rotate it around and up and down. So we did a couple of tests and a couple of calibrations in order to make sure that this worked before we went out into the field. First, we did a calibration test to see how far away things had to be. As you'll see, the numbers on the top right indicate how many inches away from the target we are. And as we get farther away, the sensor gets more and more, the laser gets more and more difficult to see. Another thing we did is we checked to make sure that we could go and that we could see the laser lights in an object. So I chose the house in my apartment. And as you'll see, this is photos of me scanning it. So, collection of data using the LiDAR sensor. One second. All right, fine. Get this to load. So, this is me outside. We had a couple of problems taking the pictures. First off, you'll note that there was a lot of ambient light at the Idea Factory. Not pictured in this photo, but the Idea Factory itself was lit. But there's also ambient light coming from the construction over Zupnik Hall, 6-foot light coming from the IRE building, from the computer instructional building. There were also lights down here on the thing itself. So the way we went and did this is we tried to minimize the ambient light where we could. So I went and took a bunch of shirts and just stuffed them into the light holes. Also not pictured is the sensor, but the LiDAR sensor is currently on. So you can see the light here. One thing I couldn't control for is I couldn't control for the weather. It had been raining earlier in the week. And one thing I noticed is that the parts of this surface that were wet were a lot less reflective. It's much easier to see the sensor off of the dry part of the base than it is to see the lights down here where the stone is wet. So that was something I had to correct later on by applying masks once I had the data. But this is me taking pictures, doing the sensing. Yep. Once I had the sensing, the data had to be processed. So the way we processed the data was we used this color picker script in order to go and find out what the in order to figure out what the mask we had to apply is. Then I have this script called new-ish. I know, it's amazing. Wait a minute. No, I have this script called it's homework 8 GPT, but I might have closed it. Regardless, I have homework 8 GPT, and the way homework 8 GPT worked is it went and took the pictures and it went and made the things. So where are screenshots? Desktop. So this is a picture of me taking the HSV, taking the initial raw data and making the HSV mask. So you'll see we have the raw photo, which leads to this. Meanwhile, that position led to this point cloud over here. This is me creating the mask for the second position. And this is the point cloud for the second position. This is the third position, point cloud of the third position, and so on. So to conclude, we had to go make the final point cloud, which is right here. This is my final point cloud. There are lots of problems with it, but is what it is.